This was the seed cane that was cut around August 15th, 20th to plant this field. It was planted as whole stalks. Everything looked good in the fall, looked good in the middle of the winter, and then we had to freeze too far, right? That last freeze kind of was the final nail in the coffin. So, Charles, this looks like about what y'all had, I believe. So, well, can't keep all the family secrets. I don't think y'all the only one. So let's kind of set the stage. What's going on? I mean, right now, this is cane growing weather. I tell people if the air conditioner is coming on at night in your house, you are making money. You may not like the electricity bill, but you are making money. So pay the bill. It's good cane growing weather. So right now, what's going on? I mean, this crop is having photosynthesis. And the main job of photosynthesis early on is to build the house. You got to build the warehouse. You got to build the factory. And the first job, and look, sugarcane is a C4 large tropical grass. It is grabbing lots and lots of carbon from the atmosphere and putting it into, first of all, structural carbohydrates. So you got to build a house. You need cellulose, hemicellulose, and the lignin to glue it together to build the number of stalks, the height of the stalk, the diameter of the stalk. And so the first goal right now, there's not a whole lot of sugar production going on. And there doesn't need to be because there's no place to put it. So right now, this cane is happy. It's growing. It's doing what a big tropical grass is meant to do. It's got good population, good height. It's building the factory. So the grand growth phase in Louisiana occurs from the first or second week of June to about the second or third week of August. And when we say grand growth, we're talking about an inch a day of growth. So cloudy days, we might be dialing it back a little bit, but look, by the rest of the week with the weather forecast, we're going to have some serious growth. And this cane is happy growing. And then all of a sudden, we got to plant cane. We're probably going to start planting cane week after next in some spots. And all of a sudden, that below ground part is not fully mature. And you don't plant cane with a bag of seeds. It's not in the warehouse. Next year, the year after, and the year after, your livelihood is all underground. And so it's the job of that plant. You got to think about that underground crown. You see the picture that we passed out, or that stool of cane. The job of that plant is to fill up the gas tank. You got to fill it up. We built it. Now we got to fill it up with sugars and other carbohydrates that are going to sustain it over the winter and leave enough energy and enough buds to germinate late next February into March. So what happens when we cut this in August? We have an immature underground stalk portion that was, again, very happy growing. Now, instead of carbohydrates going into the bottom of the stool, what happens? Eyes germinate. So instead of carbohydrates going down into the stool, we're burning gas to germinate new growth. So instead of packing carbohydrates below ground, it's now a source of energy. And what happens? Hopefully in mid-January, we get freezes, so we kill the growth back. We might warm up. We might get another sprout of eyes. Every time we sprout eyes, what are we doing with energy from the bottom of the stool? We're not filling up the tank. We're emptying the tank. So we have just not done a lot of research on how to handle seed cane. And nobody plants a cane crop to plow out in first stubble. This should have been plowed out. We thought it would be a good stop on field day to talk about and introduce some of the work that we aim to initiate on how to best handle seed cane, which will have some benefit on how we best handle plant cane in the fall. Maybe we need to start thinking about it as a spring crop in the fall. work it. Maybe it needs a little fertilizer, who knows, but we're going to initiate that work. So with that, there's always a disease angle. I want to introduce Dr. Andre Gama. He's a plant pathologist with the LSU Ag Center.
Thank you, Kenneth. Good morning, everyone. So like Dr. Gravois mentioned, my name is Andre Gama, for those who don't know me. Like Dr. Gravois mentioned also, I am the pathologist. So we usually look at pathogens, right, in our lab, right? So we focus on the pathogen side of things, which are very, very tiny microorganisms that gives you guys a headache, right? So I'm going to continue talking about the issue that Dr. Gravois mentioned, right? There is a concept in plant pathology, so my field of work and research, that is called a disease triangle. Have you guys heard of that before? Disease triangle? Some of you? No? All right, some of you yes, some of you no. So the disease triangle is a concept in plant pathology that says that for disease to happen, we need three things. That's why it's the triangle. We need the pathogen to be virulent, so to be able to cause disease. We need an environment that is favorable to disease development, and we need a host that is susceptible to the disease. Okay? So we need these three things. So you can think of the plant, the pathogen, and the environment where those things are at. All right? So just by looking at these guys, so one of the sides of the triangle is the host, so the plant. Which plant do you think is more prone to being sick? These guys right here, or those guys right there, right behind you. These guys right here, right? So these are weaker. They cannot fight that infection as good as we can. So those carbohydrate reserves that Dr. Gravois mentioned are important for several things. Also, the plant itself, it produces compounds inside of it that can fight some infections, right? So if they're weaker, they cannot produce as much. So if they're emptying the tank, like Kenneth mentioned, they cannot fight these infections as well. We, as of last spring, so spring 2025, we have been visiting some fields affected by this issue with seed cane. So fields that were cut for seed in the first stubble are not coming back from the winter freezes. And we wanted to look, as usual, what I do in my lab is I look at the pathogen side of things. So we started looking at the pathogen side of things, and we noticed that in a lot of these, in the vast majority of the fields affected by this problem, we had Phytophthora. Phytophthora is a fungal-like organism. It's not a true fungus. It is a noomycete. So it's more closely related to algae, actually, that really likes the soil and likes to swim whenever there's water in the soil and likes to get into the roots and cause you guys trouble, right? We noticed that in a lot of the roots from affected fields. However, a lot of times, if the plant's looking like that, it can fight the pathogen. But if it's looking like this, he can't that well, right? So we notice a very strong association of these pathogen with fields affected by this. And we also noticed that in the worst fields, we saw some high nematode counts, especially the lesion nematode. So what the lesion nematode does is it feeds off the roots. So it basically opens the door for that pathogen to come in, right? The roots have some outer layer that protect the plant against this pathogen. But if the nematode chews and feeds off that root, it basically opens the door, the pathogen comes in and causes trouble, right? So we did some greenhouse work. We're going to repeat this year. Unfortunately, there's nothing we can spray, but remember the disease triangle, guys. We have the environment, we have the host, we have the pathogen. We can try to do something with the host to help it fight that infection better. So we're looking at nutrients in a collaboration with Dr. Tubana's group, Dr. Saulo Castro's group. We are looking at nutrients that maybe can help in the greenhouse first, and then hopefully take those nutrients to the field if they work. Some plant defense response activators. There's some things you can spray on the plant that basically what we call in plant pathology, prime these plants to fight this infection. We're also testing that because unfortunately there's no fungicide that is labeled for the oomycetes. In fields that you have a lot of nematodes, it's also advisable. Dr. Tristan Watson has research on nematicides that are effective in sugarcane. So that could be another tool that could be used. But we are looking at the whole triangle this time. So pathogen, host, and environment. So we're collaborating with plant physiologists as well at a USDA, with agronomists here in the Ag Center, and with other researchers, nematologists, Dr. Raj Singh, other pathologists too, to try and address this issue, right? So this is all I have for seed cane. But of course, as a plant pathologist, and if you guys grow sugarcane, you probably saw way more disease problems, right? We deal with all the other diseases that affect sugarcane in my lab. So we are also working at this field right here. If you look at one of the signs, it says sugarcane yellow leaf virus research. Dr. Flasco leads that project, but I helped her with that project as well. Out of that project, we're trying to understand what this disease that's called yellow leaf disease. So it's not the yellow canopy syndrome, guys, it's a different thing. So the yellow leaf disease does not cause any external symptoms. So you don't see any symptoms in the plant, but it's a virus that gets inside the plant and causes some disturbances. Now, if those disturbances are affecting yields, we still don't know. We're investigating this in this trial. But out of these trial that we see in the field here, we developed a tool that can quantify the virus inside the plant. We also identify where to get our samples from in the plant to make it more effective and more basically efficient the way we sample for this disease. To tell you guys if your field is affected by this disease, we highly recommend that you guys send us samples from fields you want to use as a seed cane, so we can test them. This work is free for growers around Louisiana because we are sponsored by the American Sugarcane League to provide you guys with this service. So you guys just give me a call, give any extension agent in your parish a call, and we can coordinate to pick some samples. And we test for 4 main diseases. This disease that I just mentioned, we also test for mosaic, which is way worse than yellow leaf disease. This is a known fact. Yellow mosaic can be very detrimental. We don't want to plant anything that has mosaic. We also test for ratoon stunt disease that luckily we never found in Louisiana. So we've been doing a good job of keeping that disease away. For just comparison, in some other countries like Brazil, that is a big sugarcane producer, there's about 30% of the fields infected. We survey, we never found it here. So good, let's keep it like that, right? And also leaf scald. We tested for leaf scald. Most of our varieties are resistant to leaf scald, so we don't see much problem, but we did find some leaf scald. So if you want to test your fields that are going to use a seed cane, just give me a call, or any extension agent in your parish, like I said, and we can coordinate some pickup for the samples. So besides the virus research and the seed cane research that we're going to do, I also test the varieties that are nearing release for susceptibility against 2 main diseases, smut and leaf scald. So we have on the other side of the road a field trial where I make those plants sick on purpose. I make those plants, I put a lot of pathogen in those plants, and they express the disease. The factor that is showing there, because we have the same level of pathogen, the same environment, right? Remember the disease triangle, guys. The only factor that is different is the host, because there's different varieties. And then we can look at which variety is more resistant. So when it gets released, we can tell you guys, hey, this variety is resistant, this variety is not very resistant to these diseases, so we can keep an eye out for that. Another problem, you guys, I can assure you guys saw this disease in your field. You may not recognize it at first, but it's brown stripe. If you plant 299, you saw brown stripe. It's a given thing. It's a fact. It's there. How much problems is it causing? We don't know, because it's a new disease as well. We're looking into that. But also, brown stripe has been linked to stresses. It usually shows up after the freezes in the spring, or after you spray a herbicide. I don't know if you guys notice, after you spray some herbicide, post-emergence herbicide especially, you usually see some brown stripe. So again, we're taking that systems approach, looking at every aspect of that disease triangle, the host, the pathogen, and the environment, to try and address that issue. So we're collaborating with Dr. Foster. Dr. Matt Foster is the weed specialist here, to see which herbicides are actually giving the plant more, is actually making the plant more stress, and then allowing brown stripe to come in and causing some disease, right? Allowing the pathogen to come in and causing the disease. We're also looking at the pathogen itself in the lab to look at what fungicides are most effective against them, against the pathogen. And also in the greenhouse, we're going to do some work, also in collaboration with the agronomists. So we're going to test some of the nutrients we're going to use against these guys here that are in the soil, to see if they are able to also help with the stresses that are causing the plants to be more prone to the brown stripe pathogen, right? Last but not least, I wanted to talk to you guys about rust. If you grew 803 this season, you probably saw rust in the spring, right? I've visited many fields that we saw some rust in 803. Rust, luckily, we have fungicides that are very effective. The Dr. Hoy tested several fungicides that were very effective against rust, so we can spray against rust and protect that new growth that is coming, the more photosynthetically active growth, to protect that part of the plant. However, what if we can kind of measure the environment and know when the rust is about to appear? That'll be better, right? Because then you can spray a little bit earlier your susceptible varieties. In the resistant varieties, you guys probably won't see rusts, but in the susceptible varieties, you may. So you may want to spray your susceptible varieties, and then we are developing a model that can give you guys that answer. So you guys could. The intent is hopefully next season, in next spring, you guys can go to our website and say, "Oh, conditions are good for us. Let me go and scout my fields for my susceptible varieties." Right. The resistant varieties, the breeders, Dr. Blanchard, Dr. Baisaki, Dr. Kimbing, they do a great job at incorporating one gene that is very effective in the resistant varieties against brown rust. It's called the BRU1 gene. If the plant has that, I've never seen any variety that has that gene that shows rust. But some of our varieties don't have it, just like 803 right there. So 299 has it, 885 has it. You most likely won't see rust in those varieties. If you see, call me ASAP, because I want to collect the pathogen and see what's different with that pathogen. So that's the intent. So we want to try to model the environmental conditions and tell you guys when would be a good time to go scout. Oh, conditions are good for us. Let me go check out my fields. All right. So that's all I had. Do you guys have any questions for me or Dr. Gravois? Yes, sir.
Have you seen much difference in the cane term? Started like September, first October, or that's still too early to see much difference?
That's a very good question. So as of now, Dr. Gravois can help me with that answer. But as of now, anecdotally, so just looking empirically, right, we saw that fields are cut earlier for seed or early in the grinding season were the most affected ones. So when fields were cut a little bit later, we didn't see these issue like very, very much, right? So I went to farms where they cut a few rows for seed, and then they came in like a month later and cut for grinding. No problem where they cut for grinding, problems where they cut for seed. So it's hard to say when exactly, when is that cutoff, that threshold. But there's definitely it looks like when you cut is playing a big role in this problem. Right, Kenneth, if you have to add something.
Yeah, the minute you get a good theory about plant cane and seed cane, then you find the exception. Sometimes it's a moving target. So we just initiate some research, and every time we do that, we learn something. All right, thank y'all.